Lesson 5. Solving Quadratic Equations. Solving a quadratic equation is an important skill in mathematics and in this course. A quadratic equation is simply an equation of the form ax²+bx+c equals 0, where a, b, and c are all real numbers and a is not equal to 0. So a quadratic equation has the form ax²+bx+c equals 0, where a, b, and c are all real numbers and a is not equal to 0. As a result, the equation has a degree of 2. Solving quadratic equations means finding the zeros or the x-intercepts. So quadratic equations have a degree of 2, and in order to solve a quadratic equation, we need to find the x-intercepts, also known as the zeros. There may be two solutions to a quadratic equation, one solution or no solutions. So a quadratic equation can have two solutions, one solution, or no solutions. To solve a quadratic equation, you can use one of three formulas. You can complete the square, you can factor, or you can use the quadratic formula. So there's three ways to solve a quadratic equation. You can complete the square, factor, or use the quadratic formula. When completing the square, make y equals 0, so that you can find the x-intercepts. So the first step when completing the square is letting y equals 0 in order to find the x-intercepts. Let's look at an example. So first we let y equals 0. Now we complete the square by factoring out the greatest whole number factor from the first two terms. That would be 2. 2x squared divided by 2 is x squared. 12x divided by 2 is 6x. Now we complete the square by dividing the coefficient by 2 and squaring it. 6 divided by 2 is 3. 3 squared is 9. The coefficient of the x has to be divided by 2 and squared in order to get the constant term. But we add and we subtract the constant term. So we do plus 9 minus 9. Then we remove the negative 9 from the brackets, but as always the 2 is acting on it because 2 acts on everything in the brackets. Negative 9 times 2 is negative 18. Negative 18 plus 7 is negative 11. Then here we factor the perfect square trinomial. We take the square root of x, we take the square root of 9, x plus 3, and then we square that. X plus 3 squared. 0 equals 2 times x plus 3 squared minus 11. Now all that must be done is to isolate the x term. This will give you the x-intercepts of the quadratic equation. Now all we have to do is isolate the x term to get the x-intercepts of the quadratic equation. To isolate the x term, we add 11 to both sides. That's the first step. Then we divide both sides by 2. So we added 11, bringing this 11 to this side by adding 11 to both sides. Then we divide both sides by 2. This gets rid of this 2. Then we find the square root of both sides. Remember, there will be two roots, a positive and a negative one. To get rid of this squared of the power of 2, we need to take the square root of both sides. And we need to take a positive and a negative root, because a square root always has a positive and a negative root, like we did here. Finally, we subtract 3 from both sides. We get our answer. Therefore, these two solutions are positive root of 11 over 2 minus 3 and negative root of 11 over 2 minus 3. Notice that we use rational numbers and radicals. We want our numbers to be exact. If it is possible, you may be able to simply factor the equation. That's the next method to solve. It's the simplest method of solving. Then use the AB rule, which states that if two numbers are multiplied to give 0, at least one is 0. The AB rule states that if AB equals 0, then A equals 0 or B equals 0. Let's look at an example. Y equals x squared plus 2x plus 1. We let y equals 0. Then we factor the equation. This is a perfect square trinomial, because if you divide this coefficient by 2 and square it, you get the constant term. 2 divided by 2 is 1. 1 squared is 1. So we can factor this perfect square trinomial. We take the square root of the first symbol, the square root of 1, we take the square root of x squared, we get x. We take the square root of 1, we get 1. Then we take the sign in front of the coefficient. It's positive. X plus 1 squared. Finally, we isolate x in each factor on the left side. Finally, we follow the AB rule. If x plus 1 times x plus 1 equals 0, then x plus 1 equals 0 or x plus 1 equals 0. Since x plus 1 equals 0 and x plus 1 equals 0 are the same thing, there's only one root. So we isolate x plus 1 equals 0 for x. We isolate for x. X equals negative 1. Therefore the solution is negative 1, and there's only one solution. Lastly, you could use the quadratic formula. The quadratic formula is handy because it gives exact answers, and because you simply need to plug in the values of a, b, and c into the quadratic formula. So the quadratic formula is basically the method that you would use to find the exact solutions to a quadratic equation. This is the quadratic formula, and all you have to do is simply plug in the values of a, b, and c into this equation in order to find the exact solution to a quadratic equation. The formula is x equals negative b plus or minus the root of b squared minus 4ac over 2a. Let's find the value of a, b, and c in the below equation. Y equals x squared plus 2x plus 1. The coefficient of x squared is a, so it's 1. The coefficient of x is b, which is 2. And the constant term is c, which is 1. If you wish to find out how many solutions there are to a particular equation, there is a simple formula to find the number of solutions, also known as the discriminant. The discriminant is b squared minus 4ac. So the discriminant is used to find out how many solutions there are to an equation. And the discriminant is b squared minus 4ac. If b squared minus 4ac is more than 0, there are two solutions. If b squared minus 4ac equals 0, there is only one solution. And if b squared minus 4ac is less than 0, there are no solutions. So b squared minus 4ac is more than 0, we have two solutions. If it's 0, we have one solution only. And if it's less than 0, we have no solutions. Let's use the above equation and check how many solutions there are. Y equals x squared plus 2x plus 1. A is 1, b is 2, c is 1. We have the discriminant, b squared minus 4ac. Simply plug in the values of a, b, and c into the discriminant. B squared is 2 squared minus 4ac. 4 times 1 times 1. 2 squared is 4. 4 times 1 times 1 is 4. 4 minus 4 equals 0. Since the discriminant is 0, the quadratic equation has one solution. Solve. So, because the discriminant is 0, the quadratic equation has only one solution. Now we will solve using the quadratic formula. We simply plug in the values of a, b, and c into the quadratic formula, which is x equals negative b plus or minus the root of b squared minus 4ac over 2a. we have negative 2 plus or minus the discriminant over 2a. We know the discriminant is 0 from the above calculation, so we have 0 under the root. Then we simplify. Negative 2 divided by 2, because the root of 0 is 0. Negative 2 divided by 2 is negative 1. So therefore the solution is negative 1, and there's only one solution. Here we have graphically the different possibilities we can have with a quadratic equation. We can have no solutions where the parabola is above or below the x-axis completely, and in this case the discriminant is equal to a negative number. It's less than 0. So here the discriminant is less than 0 and the parabola is completely above the x-axis. So there are no solutions. We can have one solution where the parabola intersects the x-axis at one point and there's 1, 0 or one solution. And in this case the discriminant is equal to 0 because the equation has one solution. Or we can have two solutions where the parabola lies below or above the x-axis and intersects the x-axis at 2 points. Where it intersects the x-axis at 2 points, the discriminant is greater than 0. So the discriminant is positive. And because the discriminant is greater than 0, this parabola has two zeros, or two solutions. Here and here. And that's all for lesson 5, solving quadratic equations. Be ready for next lesson, lesson 6, determining a quadratic equation given its roots. Also, like and subscribe our page. Lastly, if you would like, click on the video on the screen to visit the next lesson, or click on the playlist on the screen to view all videos in this course. Thank you.